Hi everyone, welcome to the DC20 Summit. This event is Step Up and Switch to Efficiency. My name is Anu-Riikka Vuorinen and I am the Global Product Manager for the OTDC switch disconnectors. I have been in this role since 2018 and I have here with me Antti Elo, who used to be the PM for these OTDC switch disconnectors previously. So welcome Antti.
Thanks Anu-Riikka and thanks for inviting me here. I'm delighted to be here. Like Anu-Riikka was saying, my name is Antti Elo and previously I was the Global Product Manager for OTDC. Currently I'm working in the Electrifications Digital team. That time when I was the PM for OTDC, a lot of interesting things were happening in the market. First we saw the transition from 600 volts to 1000 volts. Then once we got there, we started the transition from 1000 volts to 1500 volts. How about now? Have we stabilized somewhere? Is there something new coming out?
Yeah, that is true. When I take over the role from you, the transition from 1000 volts to 1500 volts was quite quick. So now everything that is developed in the photovoltaic side is for 1500 volts. So no more developments going on for the 1000 volts. But then when thinking of energy storage system side, there you can still see the developments in the 1000 volts as well. But you can also see the trend that also in that side we are moving towards the 1500 volts as a standard. But what is interesting in the photovoltaic side is the discussions over the 2000 volts. So that is constantly happening in the background. So was there any discussions on your time when you were the PM for the OTDCs about the 2000 volts?
Actually there were. The craziest one, they were already, we weren't even on the 1500 volts, but then there were some crazy people who were already asking for 2000 volts that time. Of course, that was a wish or hope that time, because if you think you're moving from a low voltage to medium voltage that time, this step was just too much. How about now? Are we getting there? What's the situation?
Yeah, as you mentioned, there is no standard for the 2000 volts currently. So of course that makes it a little bit trickier to 2000 volts, but I foresee that in, let's say, 18 months we are going to definitely see some solutions also for the 2000 volts, and we need to be prepared for that 2000 volts as well. But when thinking about the 1500 volts solutions from our side, so we have quite a wide range from OTDC side for that voltage. So we are able to go from 315 amps up to 1000 amps in the IEC side, and then from 250 amps up to 1000 amps in the UL side. And what is new, next year, in the beginning of the year, April 21, we are going to be releasing a new optimized 2-pole switch for 1500 volts in the current range of 100 amps up to 250 amps. So we are really pushing forward the 1500 volt family yet again. And Benjamin Lehmann, who was starting the project since I left to my maternity leave, Benjamin took over the OTDCs and started the project for this current range of 100 amps up to 315 amps. So Benjamin, maybe you can highlight a little bit about the background for this project and what was the need for this current range.
Hi guys, thanks for inviting me and thanks for having me in this interesting webinar. As Anu-Riikka mentioned, my name is Benjamin Lehmann and I'm the Global Product Manager for fuse gear products for Inline 2 and for Slimline. I was previously taking care ad interim for Anurika's range OTDC during her absence. Yes, so during the time we noticed that the transition on the market was ongoing from 1000 volt DC to 1500 volt DC. It became obvious for us that, okay, we need to follow. We had already the range available, as mentioned before, from 250 to 1000 amp for UL and for 315 to 1000 amp for IEC. But there was also the need for lower currents at the higher voltage level. So that was when it became obvious, okay, we need to start a project. We need to dig deeper into it. Then we identified, okay, the range from 100 amp to 315 on IEC side and from 100 amp to 250 on UL side. Those are, let's say, the most wanted ones for the near future. And that is the reason why we started our project, so-called Aurora, to develop a dedicated switch in that current levels. It is not only the same technology, but it is also as our Sunday range, so as the bigger range, but it is also more compact. So it is an even lower frame size, so that we can fit it in smaller enclosures. Yeah, so I would say our product is made and ready for the future.
Thank you, Benjamin. That was really highlighting the background for this project. So as mentioned, our current solution for the 1500 volts is a 4-pole switch, which is way too big for the applications where it is used. So that's why we are really developing now something new, 2-pole switch for that current range and for 1500 volts. And I will explain you in the next session more detailing about our pole structure. What makes our switch performing such highly in 1500 volts. Let's have a closer look on our pole structure that we have for the OTDCs in the current range of 315 up to 1000 amps in the ISC side, and then from 250 up to 1000 amps in the UL side. So what makes our pole structure so unique in breaking high voltages like 1500 volts is firstly the opening angle. So we have 100 degrees opening angle, which improves the arc breaking in the arc chamber. So in other words, we are really stretching the arc. Then we have multiple arcing plates on the arc chamber, which are of course guaranteeing many jumping points to the arc. Dual magnetics are optimizing the breaking of the arc in the end of the arc path. And it is important to remember that conductive gases caused by the arc flash are guided by the long egg hose tubes designed in the pole. Symmetrical pole design enables also the independent polarity, which of course makes easier also the installation. Inspection window for a direct view of the contact positions also creates a double security for the position indication. And last but not least, the knife contact maintains the same performance even after the fault. So we are only pushing the contacts more firmly together at excessive current flows. So these things are making our pole structure so unique and mind-blowing. So the solar market is really global market. You need to have certificates that are covering the all the countries basically. So in addition to the IEC and UL certificates, we also have the CCC and EAC certificates. So we are really matching the need from the global perspective.
Sounds good. That time when we started developing this newest product, we got a requirements from Australia specifically for the BB2. It was a must on the standard, so we included some of the versions. How about now regarding the BB2?
Yeah, during my time, this requirement for the DC BB2 really turned to mandatory. So now it's mandatory to have for the products in Australia this DC PV2 requirement, utilization category requirement, but no other country at the moment has this requirement yet. So generally in the photovoltaic side, the general utilization category still is the DC21P. So, but let's see how the future will turn. That is the DC PV2 trend in the future more present also in other countries.
All right. Also, other interesting or important requirements what we got from the market while starting to develop this was the high short circuit currents coming from the energy storage system side. That time there were requirements or a lot of variance in the requirements and coming from various customers. How about at the moment?
Yes, and because of those needs, we specifically designed products for the ESS side. So we have tested now the OTDCs from 315 amps up to 1000 amps for the higher short circuit ratings. So we have done the tests with fuses, so we can go as high as up to 100 kA, and without fuses we can go as high as up to 63 kA. So as a comparison, in the photovoltaic side, as you know, the 10 kA ratings are really like maximum. So you don't need higher short circuit currents in that field. But in the ESS, then the short circuit currents are really going higher. So we are really fulfilling the need in that side as well.
Good. And that time, especially the ESS requirements, they were coming from Norway because they were electrifying the vessels. And in addition of the higher short circuit currents, there were also the requirements for the marine standards like DNV GL. Do we have the right standards at the moment?
Yes, during my time we get the DNV GL certification for the whole OTDC range.
Good. So
that is now covered. But nowadays in the ESS, the marine is not the only sector that we are getting these higher short circuit current requests. So the ESS is really now covering the whole renewable energy sector.
All right. So for me, it sounds from country point of view, also from the application segment point of view, we are well covering all the standards, what is required from the customers or in the country. How about then, why should customer buy the OTDC? Why is it better than the other ones on available on the market?
Me and Benjamin are going to be explaining why the OTDC and OT switch disconnectors would be the best fit for the applications. In the photovoltaic applications, you usually are using OTDC inside of the DC combiner boxes, and the main purpose inside of the DC combiner box is to allow the safe maintenance in the arrays and also, for example, the reliable fuse replacement. So that is the main purpose of the OTDC.
Yes, that's true. And we have 2, 4 and 6 pole variants available in our portfolio to disconnect 1, 2 or 3 DC circuits.
Yeah, with only one switch. And
yes.
Those are up to 1500 volts. So that is really important. And then what is really, let's say, highlight of our switch is that we have the DC PV2 ratings, which is quite rare. And compared to DC21B, the PV2 ratings are allowing a much more higher performance.
Yes, also the test requirements are much more demanding because we are testing make and break capability of the switch up to 4 times of the nominal current, and also the operational performance is tested up to 8,000 operations instead of 1,800 operations.
Yeah, and now we can go as high as up to 10,000 mechanical operating cycles with our OTDCs, which is really a lot, and improving the endurance of the switch as well. But not only as the higher ratings, but we also have a really compact switch, so we can disconnect the 1500 volts with only 2 poles,
yes,
which is really important in the DC combiner box, because our switch is really compact in size.
That's true. So we are not demanding the combiner box manufacturer to increase their enclosure size due to the switch size as it has been in the past.
Yes. And when thinking about the ESS, so there we have other important features in addition that we need to focus on. So for example, in the ESS, we have higher source circuit ratings. So before I went to my maternity leave, we tested our OTDCs with fuses up to 30 kiloamps. And now during your time, you even further tested the switches.
Yeah, because we noticed on the market that the demand is actually there for 50 kA, for 70 kA, and even for 100 kA. And that was exactly what we did. We tested our switches up to 100 kA in combination with fuses. But not only that, there was also the demand for higher short circuit withstand currents up to 1 second length. And there we are now with these variants from 315 amps up to 500 amps. We are going as high as up to 10 kiloamps, and then for the 800 and 1000 amp variants, we can go as high as up to 63 kiloamps. So really excessive current ratings compared to the PV types, where we have only the source circuit values of 10 kA. So we are really increasing the ratings in the short circuit side. And when talking about these the ratings and the products for the ESS, we also have the OTs. So we have also tested the OTs from 1600 amps up to 4000 amps for higher source circuit values. So there we have also the short time withstand current up to 100 kiloamps. And then we have also quite high maximum the let through peak currents.
Peak currents, which are really impressive.
Yes.
Impressive. And then what is also important to remember is that especially in the ESS and marine side, the electrical interlock is really important feature, and that we have for the OT switches.
Yes, and as we know, it's even required by law or by the standard to have an electrical interlock available, especially in the marine sector.
Yeah, that is really important. And these are only the few points that we wanted to highlight, that why to select the OTDCs and OTs for your applications in the ESS and PV side. I like to highlight few additional things in the mine and Benjamin discussion. So regarding the ESS application, if the requirement is for the no load break, so then OT switch disconnector is the perfect solution because it has the DC20 utilization category. But if the DC20 is not sufficient enough, so you would need to have a load break switch, then OTDC is the perfect solution. And what is really worth of highlighting is that there are no additional connector bars needed for the OTDCs, and we have been able to cut down the power losses of each pole and able to create a much more power efficient switch. And therefore OTDCs were awarded with this solar impulse efficiency solution label, which shows that we are really committed to create a cleaner and sustainable future with our products. And now I want to thank you all for participating this event and wish you all a good rest of the day and enjoy rest of the events. And if there are any questions for our event, please send those to us. And thank you all for coming.